the law of multiple proportions. So last week we talked about the law of conservation of mass, which says that matter can't be created or destroyed, it can only change form. And we talked about the law of definite proportions, which says essentially every chemical compound has a recipe. And the two of those laws together helped Dalton to form his atomic theory, which was pretty impressive, although not completely right. So that's a test question about what two laws helped him form his theory. Today we talked, your book, your reading, talked a little bit about the law of multiple proportions. We talked about that a little bit last week too, how, setting the temperature. Look at that. Even before the lab starts, we turn on the air conditioning. So the law of multiple proportions just says that two elements combine to form different compounds, if they can, which that can only happen for covalent compounds composed all of nonmetals. Ionics can't do that. So the law of multiple proportions only applies to covalent compounds. And if two elements can combine to form multiple types of compounds, such as carbon monoxide and carbon dioxide, they're both composed of carbon and oxygen, but in different proportions, then as long as one element has the same number of atoms, and, you know, there's one carbon here and one carbon here. If that weren't the case, we'd have to fiddle with it. Then there'll be a whole number ratio between these. Of course, we all know that the law of multiple proportions, you know, you can't have half an atom. So if you have carbon monoxide, it has one oxygen. Carbon dioxide has the same number of carbons, it has two oxygens. So there's a ratio of one oxygen to two oxygens. That's essentially what the law of multiple proportions says. A simple whole number ratio.
It doesn't zoom.
It doesn't zoom?
No.
It doesn't zoom anymore, that's what you're telling me? Okay, so camera disaster 15. I ordered a new camera last week, like on Tuesday. I went home and purchased a new camera on Amazon, and I got an email yesterday from the guy I purchased the camera from. The camera's $21, and it was just like my old one, which was not $21. So I was so excited. He's like, oh, I'm out of stock. And I'm like, oh, you marked the price wrong, and you don't want to sell it to me for $21. But I will try again today, and perhaps a new camera will come someday. But this is camera 3. Hopefully 4th camera will be a charm. But anyhow, no one's absent. Well, maybe Grace will be absent. So I will take the things and put them where I won't catch them on fire. Right there. So, Dalton's atomic theory is kind of our big topic today. And he had 4 parts, which I'm actually going to look at the test right now because I think it literally says, list the 4 parts of Dalton's atomic theory. And that is, it does not, does it? No, you do not have to literally write Dalton's atomic theory from memory. That's good news, because, but it's very important to understand because atomic theories come a long way in chemistry from Dalton, but he did a great job, and without what he did, we couldn't have figured out what we know now, and we're certainly not done. But anyhow, does anyone know a piece of what he hypothesized about atoms, Lily?
All matter is composed of small particles called atoms.
Okay, so, and what did he think about atoms? That's wrong. This piece was wrong.
They're indivisible.
He thought they were indivisible. We now know that we can divide them, but, you know, it liberates a lot of energy when you do. Anyone else know a piece of Dalton's theory? Okay.
That all atoms with the same element have the same properties.
Right.
And the opposite also applies.
Right.
That
element has unique properties, and there's a tiny piece that's wrong with that involving isotopes, because isotopes have almost exactly the same properties. If you have two isotopes of carbon, they behave just like carbon, except their atomic mass is a tiny bit different. I don't think we learn about atomic mass until like Module 5, though, so we'll get there. But that's almost exactly right, and it doesn't affect anything that I've ever done in chemistry anyhow. Anyone else? A third piece of Dalton's theory? I'll help you. Yeah. You got, so there's only one piece left, essentially. Compounds form when atoms join together in simple whole number ratios. You can't have one carbon joined with half an oxygen, for example, right? This doesn't happen. So atoms only come together in whole number ratios of atoms, because he said atoms are indivisible. For our purposes, that's essentially the case, because we're not doing nuclear reactions.
Do you need to know that for the test with this four?
No, you won't have to list the four. You will have to know that the law of definite proportions and the law of conservation of mass were the two ideas that drove him toward the formulation of his atomic theory. So, a few definitions. Compound. What is a compound? Chloe?
Substances made of two or more elements.
Okay, and they're chemically bonded together. They're not just mixed together. So compound, and it's a pure substance. So when we talk about pure substances, is this the module I need to draw a little graph on? Probably. Nope, that's next week. Okay, elements are things that are on the periodic table. Compounds are made of two or more elements, and they're chemically bonded together. They, those two things, elements and compounds, are pure substances. And anything that's not a pure substance is some kind of mixture. Things that are mixed together but are not chemically bonded together. That's next week, though, I think. Chemical symbols you guys are already well familiar with, because you already took a quiz on the first 20, and I think next week or the week after, so we know, we'll have a quiz on the second 20, so 21 to 40. Looks like next week, October 7th. Is that next week? No.
No, it's 2 weeks.
Okay, 2 weeks from now, you'll have a quiz on the next 20. So start working on those. The quiz will be essentially identical to the last quiz, so make sure you know. I don't have the periodic table, but if I say, I don't know, if I say Cu, you say copper. If I say chromium, you say Cr. There are a lot of Cs in this one, so make sure you get them straight. But you guys did a great job, absolutely fabulous on the first quiz, so study hard. You can't correct quizzes, by the way. So that's the only thing in my class you can't correct, so study for those. Also, I think next week you have a list of 8 elements to memorize, so I'm sure you'll quickly handle that. But do memorize them, because even like 6 months from now, you'll still be using them every single day. Okay, so ionic and covalent compounds. Just as a review of last week, ionic compounds are composed of
At least one non-metal and one metal.
yes, so ionics have a metal in them. And covalent?
Just non-metal.
All non-metals. They have to all be non-metals. So make sure that you can see that heavy line on your periodic table, photocopy, so on the test you can quickly identify if something is a non-metal or a metal, because to name the compounds, which we're going to go over a lot today, you've got to know if it contains a metal, you name it like an ionic, no prefixes. If it doesn't contain any metals, it's covalent, and you name it with those prefixes. So, and that's, again, something we're going to do pretty much every week, all year. so master it. It's important. So we'll go over that during the lab. That's easy. Probably you'll want to grab your worksheets and put them in front of you, and we'll go through the lab before we do questions and stuff. Here we go. Okay. So I have my worksheet. I don't think I do. That's not awesome. Nope, no worksheet for me. Okay. Okay, great, this worksheet. Does everybody have both pages of this worksheet? Because I seem to have one extra of the third page. Like you'll have a front and a back, and then another front. Anyone need one? Okay, let me know if you discover that you do. So there are two things that we kind of need to quickly start doing. We're going to learn about percent composition today. And this is not something that you really find in your textbook, but it's math that you've already seen in this class because it's essentially the same way we calculate percent error. You did some problems this week involving the law of multiple proportions and kind of the recipe for each element and doubling or tripling or 55 and a half timing a recipe. If I do that during the lab, it's not going to be good. But that's really not the way that we do things in the lab. So percent composition is kind of the way that a chemist would actually be interested in looking at a compound. So we're going to look at how to do that first with bubble gum, which is nice and safe, and then with magnesium oxide, which is flashy and fun. So what we need to do is first people need to decide if you would like sugar-free or not sugar-free gum. So who would like gum with sugar?
I don't care. I don't care.
Who cannot chew gum of any kind?
I don't like it.
If you are currently chewing gum, please spit it out. Let's see. Who is allergic to fake sweetener? Anyone? Red dye? Anyone? Okay. So, not that we'll find out the hard way now. Red dye is a really awful thing. So you guys will have real gum, and you guys. So don't put it in your mouth yet. We need to weigh it first. Actually, let's just weigh it all together here. Do it the smart way. So your worksheet probably says, can't see it all. Mass of gum and sweetener and mass of gum. So if everyone would kindly open your gum. There we go. And then just leave it on the wrapper, and don't destroy the wrapper is the important part, because we're going to need the wrapper. And you guys can hopefully...
Do we have to chew this because I cannot?
You don't have to chew them, no. You can just use the data from other people. But just open it and lay it on your wrapper, because I'm going to weigh them. I just don't want to be touching your gum. Okay. And then we'll... Alright. So, everyone lay your gum on my sheet here, but with the paper, I think. Because we're going to stick the gum into the paper. There we go. I will attempt not to touch anyone but Jenny's gum. Okay. So we'll find the mass of the gum in grams. All of the gum and the papers and the little weighing thingy. Now, we have to make sure I'm not touching anything but the scale. Okay, so the mass of the gum with the sugar and the wrappers and everything is, I think we're getting air current here, 48.54 grams, I think. Now, what you're going to do is take your gum and leave your wrapper. So take your gum, leave your wrapper. The top one. Go ahead. Take gum, leave wrapper. You all will similarly do this. Okay. Take gum, take back wrapper. Chew gum. Oh, wait. Chew gum? let me think. I always get the thing wet, before I think what I'm doing here. So did someone write down 48 point something grams?
4 grams I did.
We wrote it down, okay. Get mass of gum with
48.54 grams.
Okay, so we have mass of gum, that's good. So you guys can start chewing away at your
Wait,
gum.
was that the mass of gum and sweetener? Is that what you just mean?
Yes, because
Okay.
the gum has the sweetener in it. And now I'm going to weigh all of this mess. So we're going to record our data. Okay, so all the papers together are 1.60 grams. So let's make a note here. So everything, what was the mass of everything? 40.
8.54.
And then what was the mass of the paper?
1.60.
Okay. So then okay, so just the gum here is going to be 46.94 grams, and we keep out to the hundredths place. And then this is the sweet gum. So then I'll pass back your wrappers, and you can hygienically spit later into your wrapper, and then we'll weigh the gum without the sweetener. So what kind of assumption am I making as we do that? What we're assuming is that all the sweetener will dissolve as you chew, and the sugar will come out of the gum. We're also assuming that nothing else will dissolve and come out of the gum, but that may not be a valid assumption, right? I mean, the red dye is soluble, it will come out, be absorbed into your body, causing you to be hyper and strange. We're also ignoring the fact that your saliva will add mass to the gum, but gum isn't super absorbent, so hopefully that won't be a big source of error. All right, so we need a little wrapper. Okay, so we're going to weigh everybody's gum, and so place your gum in the wrapper thing, and your paper. And we'll get its mass, and then we'll weigh the papers too.
I think we unwrapped it first.
I have no idea. So that's one thing I always struggled with in lab. I was much better at the book stuff than the lab stuff as a student, and really, like, reading the lab beforehand and planning out what you're going to do before you start doing it was always a struggle for me, I have to admit. My lab partner was excellent at that, though. Thanks, Julia. Okay, so the mass of the gum and the wrappers and everything is 15.23 grams. 15.23 grams. Then you can start chewing. And I'll take your papers back. It doesn't matter which paper you get back at some point, I think. Okay. There we go. So you guys, it was 15. Oh, good. She left the paper. Okay. So the mass of just the paper, 1.09 grams. No, well, 1.09. Okay. So we'll leave that there. 1.09 grams for that. So this is artificial sweetener. So everything was how much?
15.23.
23. And then that was 1.09 grams for just paper. So the gum itself would be 14.14 grams.
That's what I got.
Okay.
I can't see anything you just wrote on the board.
Okay, I'll move the camera. So, everyone's chewing, we're chewing, and while we're chewing, we'll talk about some of the other parts of the lab. So here's our data. Okay. Move when people are talking, see if you can tip it over to look at people and stuff. Okay. Do we know where my lab sheet went? Over there. So, percent composition is that line? Okay. We're going to try to find the percent composition of the sugar in the gum and of the artificial sweetener in the gum. We're making these assumptions that I mentioned before that only the sweetener will dissolve out of the gum and nothing will be added to the mass of the gum. So make a prediction. Do you think that the mass of the sweetener in the sugar gum will be larger or smaller than the mass of the sweetener in the artificially sweetened gum? Percentage-wise. Like if you think of, I'm putting sugar in my coffee, or I'm putting artificial sweetener in my coffee, and you empty one of those little packets of sugar or little packets of sweetener, which one do you think has the most mass?
Real sugar?
The real sugar. So, and you can see the real sugar gum has a bigger mass. I was actually surprised at the results of this, because I really thought artificial sweetener would have a tiny, tiny mass. And even though it isn't quite as much as the regular sugar, in past years we've found that it's a significant amount of mass, more than I expected actually. So, there you have it. So you guys will keep chewing until your gum isn't sweet anymore, and then we'll spit it out and weigh it. But until then, let's talk a little bit about the next part of the experiment. So, it says we're going to calculate the percent mass of oxygen in magnesium oxide. And you're supposed to watch this demonstration and write a procedure on notebook paper to be turned in. So while you're chewing along quietly and watching this, you need to write a procedure. So I'm not going to write it with you. I want you to try to do it yourself. And I want you to think about how you do it. You don't say, she burned up this stuff. You don't say, I burned up this stuff. You don't say, burn up this stuff. How would I say?
The stuff was burnt.
The stuff was burned up. So, that's good. Try not to say stuff, though, of course. So this is a strip of magnesium. Is magnesium a metal or a non-metal? Metal. It's a metal. It has luster, it's shiny, malleable, you can bend it. Metal strip, magnesium. And magnesium, actually it's sort of strange for a metal. I'm actually going to use only half of this, so I don't like the world on fire here, but this is one of those moments to put on your lab goggles. This is also not something that you want to look at directly. It's sort of like looking at the sun. Kind of look sideways at the metal. So magnesium will react with the oxygen in the air to combust in a flashy, happy little way.
How do you look sideways?
Yeah, I know, it's really hard not to directly stare at something, honestly, but try. So we've got magnesium metal, and it will react with oxygen in the air to combust.
And we're starting the procedure now.
Not really, because this is not the lab. This is just to show you what's going to happen during the lab. Let's hope I don't freak out and drop it. Keeping it happen. All right. Did I really only get out one match? Oh well, I'll light this thing.
Yay, sparkler.
Are we seeing that on camera? Because I'm seeing it again. Maybe I'll hold it over the metal thing in case I drop
I
it.
think it's kind of hard to see because
Okay, so you guys can see this white substance that I'm left holding here is magnesium oxide. So I had a strip of magnesium, it reacted with the oxygen in the air, and it formed magnesium oxide, which is crumbly and powdery and completely different in its properties than the magnesium was. actually have a little strip of magnesium left here that didn't burn up though. So, chemical reaction, magnesium reacts with oxygen to form magnesium oxide, and I'll maybe try to burn the rest of it just so it's not sitting around. And it's fine. Maybe it won't. It might be too coated in magnesium oxide to get on fire. So, now, of course, we can't manage to measure the mass of that reaction, right? We can't figure out how much there was, how much there is now. So what we need to do is try to contain the reaction so that we can try to measure the end product. Now, of course, you know, oxygen from the air, we can't figure out the mass of it to begin with because we can't just weigh the oxygen on the scale and figure out exactly which oxygen molecules are going to react and which aren't that are just sitting around. So, what we're going to do is try to get the mass of the magnesium at the beginning of the reaction and then the mass of everything at the end and figure out how much oxygen was added. So, get some data here. It says mass of crucible and lid. This is a brand new crucible, so it's not all contaminated. Almost never do these last more than one experiment, and sometimes they don't even make it through the first one. Thanks, home science tools. So the mass of our crucible and lid is...
Should we start writing now?
Yes, you should start writing now. This is the start of the procedure. So the mass of the crucible and lid is 20.96 grams. And you don't have to say the mass in your procedure, you just have to say that you found the mass. Okay, then the mass of the crucible, lid, and magnesium. So I'm going to take some of these magnesium strips here.